Good afternoon. Thank you very much for joining us today. I'm Ocean. I'm a postdoc at the Brain Science Institute at Imperial. Co-hosting with me today is Ali from the Bard Cancer Institute at Queen Mary. I'm really excited to have our speakers with us today, who chose to pursue one of the most challenging paths we can imagine after our PhD and actually succeed in this arena, creating impactful tech startup covering medical technology, AI, and fintech to share with us their stories. Thank you very much for joining us again. Just a reminder, this event will be recorded and part of it will be available on our YouTube channel. If you have any questions to the speakers, please feel free to post it at the Q&A message box. Beware, not the chat box, but the Q&A message box, and we will pass them to our speakers at the Q&A session. And before we start, I would like to take this time to introduce our London Postdoc Network community. So who are we? We are a group of postdocs around the London area who are building a cross-institutional network to provide career support for our postdocs. Our current activities include organizing career events like the one we have today, enhancing our networking opportunities, and also propagating career information for our postdocs, such as job opportunities and career events from other institutes. Our current committee include Clarice from King's, who is our current president, Sean and Anna Head, who are at King's, Natalia, our vice president at Francis Crick's, and Anna, who is also helping us to organize this webinar today. Mindava and Ellie at Queen's, and also me, Ocean, who is currently at Imperial. So if you are interested in joining us, please don't hesitate to contact us because we are really welcome for having new members. You can find our past events, including tips for publishing, sharing from young PI, and industrial careers sharing on our YouTube channel. And please feel free to join us at LinkedIn, Twitter, and Facebook. And for more information about us, you can check us out at our website, londonpostdocnetwork.com. I will now pass over to Ali to introduce our speakers today.
Hi, everyone. I now have the pleasure of introducing a fantastic panel of speakers. So we have Pedro, who is a co-founder and CEO of Neobe Therapeutics, which was spun out from his time as a founding analyst at Deep Science Ventures. Łukasz, who is a co-founder for Saliency.ai, which has now been sold, and also a co-founder at DeepArt UG. Nimelan, who is a co-founder and CEO at Benchmarmatic Inc., and Rodrigo, who is a co-founder and CEO at Refinery Tech, and also co-founder and CFO at Applied Behaviour Systems Limited. So we're really very, very lucky to have a real breadth of experience across all of our speakers today. So we've got cancer biotherapeutics to medical imaging platforms to fintech. So hopefully there's something that everyone here can get out of it and something that's interesting to everyone. So please feel free to get stuck in with questions in the Q&A chat for them all in the discussion at the end. Yeah, and I think I'll start by introducing our first speaker, which is Pedro. So Pedro has a background in 3D cancer models with a PhD from Cambridge, and is a co-founder and CEO of Neobe Therapeutics, a cancer biotherapeutic startup spun out from Deep Science Ventures and Cancer Research UK. So with that, I'll hand over to Pedro if you want to share your screen.
Absolutely. Thank you very much, Ellie. Can everyone see the screen?
Yeah.
Okay, great. Thank you again, Ellie, and thank you very much to the network for inviting me to speak today. I'm really, really thrilled to be here. I was a postdoc less than a year and a half ago, so I'm still quite new to entrepreneurship. We just put together Neobe Therapeutics, as Ellie said, out of a collaboration between Deep Science Ventures and Cancer Research UK at the beginning of this year. So I think I have a sort of a fairly earlier stage view on this pathway compared to some of the other speakers, and my path is also potentially a little bit different. So I thought it would be useful to sort of go a little bit into how it is that I got there and how we spun out Neobe from Deep Science Ventures, and then a few things that I kind of I think figured out as an academic getting into a startup. So, as Ellie said, my background originally was in 3D cancer models. I did my PhD at Cambridge at what at the time was a new Cancer Research UK institute that had just been opened there, which was very, very exciting. And I thought it would be interesting to share some of the experiences I had from there, because what my main project was, which is titled there, was the development of this new 3D co-culture model where we could put together cancer cells together with endothelial cells that form the blood vessels and other components of the local tumor microenvironment to form these tumor-associated vessels in a dish that we could use to find either new targets that we could develop drugs with, or we could test out, use it for drug screenings. It was very exciting at the time, and it generated quite a bit of interest, so much so that we got into the path of trying to patent this model as a drug screening model. And we got involved in sort of deep conversations with, at the time, CRT, Cancer Research Technologies, which was the sort of technology transfer office from Cancer Research UK, to see if we could take this model and patent it and maybe sort of generate a venture out of that. And it turned out that unfortunately we couldn't do that because I had just written my master's thesis that had some of the original work that we used to put this model together, and because the master's thesis counted as a prior publication of the model, we weren't really able to patent it. And this was sort of an early reality check of the cares you need to take into your project if you do want to spin out a venture out of it at some point. I went on to do a postdoc in Texas for a few years after that, continue working in this area of the tumor microenvironment, which for anyone who's out there who doesn't work in cancer is basically all of the components that you have in a solid tumor that aren't just a cancer cell. So from your immune system to your vasculature, et cetera, that all contribute to how cancer develops and how it responds to therapies. So one of the things that I did there was develop new technology where we could analyze the spatial interactions between all of these components and show how this correlated with how these patients corresponded to therapies. So it was sort of my first contact with having a more applied project, which involved a lot of very in-depth collaborations with technology partners, initially at PerkinElmer and then Akoya, which are two companies in this field. And then my other interest then was extracellular vesicles, so vesicles that are derived from all cells that can be used either as biomarkers or as therapies. And we identified new biological functions for these vesicles that could be used for the development of new therapies. And thankfully, my supervisor at the time, Raghu Kaluri, was a lot more patent savvy. So we did publish a patent on that work before we got anything out there, before we talked about it at any conferences, before we got any papers published. So we've got that patent out there, still waiting for the paper to come out, hopefully at some point soon. But that was kind of a learning process that got me to where I was at the end of my postdoc, at which point I kind of felt like I wanted to do something a little bit more applied. I'd been an academic my whole life. I got into cancer research because I wanted to do something that had sort of real life applications. And even though I really was lucky enough to work in very exciting projects in really great institutes, I was feeling that none of the work that I was doing was having any sort of immediate application. And I started toying with a transfer into the industry side of things. And I had a couple of offers, but then I just happened to be at the right place at the right time, just at the end of my postdoc, where I went to a conference and I met Kirsten, who was at the time in charge of the pharma branch of this company called Deep Science Ventures. So we've mentioned it a couple of times now. If you haven't ever got so if you've never seen what Deep Science Ventures is, it's based here in London, and it hires scientists to scope areas of technology, and not just in pharma, but also in agriculture, in computation, in energy, to try and identify new solutions for problems that are pressing, and train these scientists to develop their own ventures to respond to these problems. So one of the things that they wanted to do was exactly develop ventures in the area of the tumor microenvironment, and how all of these components of solid tumors created barriers to the success of therapies in these patients. And I happen to have just the right profile to be able to lead those projects. So they recruited me to start looking into this. And that involved a lot of initial scoping and ideation. But what was great about it was that I was able to do it free of previous academic constraints. I'd been working on the field for a long time, but obviously when you're in the lab, you're always constrained about what the grants are that you have in place, what's going to get you a publication soon that's going to move you into your next position. Whereas here I could actually have the freedom to look into the entire field and identify, okay, what needs to be done and what's the best way to do it. I was hired by them as a founding analyst to do this for about 9 months, which gave me, financial freedom to be able to do this effectively and to build the right team, to make sure that I could get the people with the right skills to help me put this venture together. And they provided me with the business support, which is really what I was lacking at the time. I had been an academic my whole life, so things like analysis of the freedom to operate. Can you actually build these ideas? Are there any patents out there that are going to prevent you from doing this? What's the ideal fundraising strategy to make sure you have the money to do this? Budgeting, etc., which I'll go into a little bit further on. So this led to Neobe Therapeutics, which is the company that we formed earlier this year. I was lucky enough to find Analyse, who was the ideal co-founder for this company. And basically what we're doing at Neobe is engineering bacteria to remodel these microenvironment barriers to therapeutic success in solid tumors. So I had the solid cancer biology background, and she had the ideal microbiology background. So the two of us together could bring both of our skills into building these products and start taking it into commercial applications, which is something that we're working on right now. So to go straight into the sort of lessons learned of moving from academia to the startup space. And I'll be happy to talk in more detail about Neobe itself and what we're doing if anyone wants to reach out to me afterwards. And again, the right place at the right time, or specifically the right problem at the right time. You may have some really fascinating science that you're developing into in your lab, but you do need something that is a desirable product right now, something that investors can see has a real life application and a clear market, and you need to know your market. What is the commercial application for the product that you're developing, and how are you going to have a good strategy to commercialize it? The perfect team is really one of the main things that you can have as someone who's founding an early startup, especially if you come from an academic background where you don't necessarily have a lot of a business background, but you've got a really, really solid idea. One of the first things that investors are going to look at is, do you have the right team to put this into practice? Do you have all of the skills you need to successfully build this product? And this is how getting Analyse as a co-founder was so important, because then what the product is that we're developing is something that spans this overlap between cancer biology and microbiology, bacterial engineering. And we both have a solid background on this. We both have publications on this. We both have patents on this. So we can prove to our investors that we've got the right team to do this. We also were lucky enough to do this in the context of Deep Science Ventures, who provided us with the business skills that we needed so that we have a clear route to market for the product that we're developing. That's really, really important. And if it's not something that you have, it's something that is really important to look out for earlier on. Startups are team efforts, so you really need to make sure that you've got someone that's going to cover all of the different aspects that you need to take this forward. And then the issue of intellectual property, and that's something that if you have an idea that you're developing in an academic position, you need to make sure that you talk to the technology transfer offices in your university to see what the possibilities are of taking that IP and developing a venture out of it, making sure you have freedom to operate in this space, that no one else has any patent that could interfere with what you're doing. Having protected IP is really one of the main things that investors look for once they're talking to. One of the biggest differences when you're looking at starting a company from an academic background is really, I don't know if anyone else is familiar with the Marvel Cinematic Universe, or if anyone has seen the new Loki show that has just been put on the Disney Plus. But the whole sort of story of that show is you have this timeline that everyone is on, and anything that happens that takes you out of this timeline is called a Nexus event, and this needs to be taken, this needs to be detected and sort of cut at the root as quickly as possible, so that you don't disrupt this timeline that we all need to live in. There's more details on it that I'm not going to get into, but what was striking to me is that when I was watching this on the show, it immediately reminded me on this transition of academic to industry, because in academia, you find something interesting, especially if you are in a well-funded lab, you have the space to go, okay, let's see where this takes me, what the interesting science is that is behind this. If you are in a startup, that's not really much of a possibility, especially in the early stages. You have a clear objective, you have clear milestones and timelines, and you need to make sure that you stay on track. And if something doesn't work, you stop and you continue to make sure that you get to your next stage. And this is, for example, the timeline that we have from our company when we talk to investors. There's very clear timelines, prototype development that opens the space to patent generation, to efficacy studies. Everything has a clear next objective and next value inflection point that will take you to the point where you can take this to the market. The good news is that as academics, we all have the skills to be able to do this. I was trying to think as I was putting this together and all of the things that I have been busy with as I was putting this conference together. Obviously, one of the main things is pitching, making sure you have a right compelling pitch that you can get investors on board with what you're trying to do, and that you can attract partners to help you develop some of this work, some potentially even academic partners. And we've got plenty of experience doing that, going to conferences, going to seminars, etc. Networking, the same thing. Even events like this are really important. So you make sure you have a wide enough network that you can go and tap into as you develop your company. You obviously have to write patents, and obviously grant writing and paper writing is not the same thing as writing a patent, but we have experience of taking our data and writing a paper around it. The skill set itself is not different, you just have to write in a slightly different language. And you need to learn a different language to get to talk to venture capital. And that's something that we're also used to doing if we get involved in multidisciplinary collaborations. For example, in my postdoc, I had to work very, very closely with mathematicians to develop algorithms to analyze our images. You have to learn a new language and adapt to it quite quickly. The two things that I would say that were really, really important, which was building the team and making sure that you can budget around your project, are things that you can get involved with in the lab. And I would say if this is something that you're thinking about, make sure that you get involved with it as soon as possible. Talk to your PI, make sure you get involved with grant writing, make sure you get involved with the budget of the lab. What's your runway? How much money do you have until that grant goes away? What's the priority? Where are you going to spend the money? Usually people. And as far as the team goes, obviously we have experience in collaboration and mentoring, but get involved in hiring. Once your lab is like trying to, get new people in, try to get involved with that as much as you can, because that's going to be really, really good experience when you're trying to fill up your company with the right people. And the right people, as I said, is really one of the main things that you can have. But at the end of the day, the main thing that we're doing is we're solving problems, and we're just solving, immediate problems that have immediate applications. And all that we do in our PhDs and in our postdocs is solving problems. So we have the skills to be able to do this. I'll just stop talking now. And, if anyone wants to reach out to me either through email or LinkedIn, just feel free to reach out, and I'll be happy to have any chats or answer any questions afterwards.
Fantastic. Thank you so much, Pedro. That was brilliant. I'm sure it sparked a lot of questions for the discussion at the end. So I'm now going to move on to our next speaker, Łukasz. Lucas is a former postdoc in bioengineering and statistics at Stanford, and he's the co-founder of Saliency.ai, a medical imaging platform, and also co-founder of DeepArt UG, a neural network algorithm that converts photos into art. So I can't wait to hear more about this. So yeah, over to you, Lucas.
Hi, thank you very much for the invitation and for this introduction. So it's really exciting to hear Pedro's talk. So my path is actually very different. I think it's very different. So it would be exciting to see that you can approach entrepreneurship from many angles. And I thought I would start with some background on what I used to do for like in the entrepreneurship space and my recent like modest successes of getting my company acquired. And then I will sum up everything with some lessons that I think I've learned over those years. So I'm kind of entrepreneur who started and tried lots of different things, starting in primary school. So as soon as I learned how to write on a keyboard, I started a local newspaper and just I was trying to sell it to everyone. And there was not enough readership to keep it for long, but that was kind of the first startup or first company that I had. Then I've had a popcorn stand and not many people were walking around on my street. So we didn't sell much, but still. We tried. Then we had a stock exchange where we had imaginary stocks in the primary school and imaginary numbers assigned to those stocks, and people could buy like for pennies their stocks, and they come back and could see if they go up or down. This didn't really take off, given that there was no real market behind that, but still it was exciting. I was getting into some copying CDs business as like in the post-Soviet Poland. That's one of the things that people were doing, and I learned my ethics later in my life. So that was my primary school part. Then in the high school, I started a software house. I was building websites for money. I started, and this worked well. I made some money in high school on that. I thought, okay, I will build a software for managing car dealers' invoices and stock and so on. And I built a really great piece of software, but there was no big market for that. Like it was just a random idea that I had in my mind and spent a lot of time on building that. Then I built an instant messenger like ICQ or like Messenger on Facebook. This got some traction, but again, there's no business around that. Later, I tried to copy some ideas or see when I was seeing some ideas overseas, I built versions, Polish versions of that. So Shopify was one big thing. I actually started around the time that Shopify started too. So it wasn't explicitly a copy, but kind of trying to do the same thing at the same time. And then there was my first success. So in the college, with one of my friends, we decided to build a website where people could submit their materials that they were preparing for a high school exam, and others could buy those materials and learn from them and prepare their own materials for that. And it was kind of borderline, like people, there were some ethics involved in that. So like the people were supposed to prepare those exams on their own, but like it was obvious that everyone was using lots of different resources. So we got actually some traction because it was actually unclear if those exams in Poland made sense. So I think we actually contributed to changing the exam itself through a website that was very, very successful actually. So for a college undergrads, we made quite a lot of money. So that felt that, okay, it is possible to build something that people buy and use, and you change something in the world. Then I took all this money that we made on this project, and I decided to build a Yelp clone in Poland. It failed completely, so we spent all the money that we made in the previous thing and just failed. And then my brother-in-law lost his job, so we thought, okay, let's do something. Let's import machines for pressing the orange juice in the shops and like try to sell those machines. So that's actually went quite well, but like it was a lot of logistics, and the brother-in-law wasn't actually that much into running the business, so that failed. I tried math tutoring on large scale, just building a school in Poland with many teachers all over. It ran for like a year or two, but eventually also didn't sustain. I tried a fantasy football website. That was the first company that I started in the UK, actually, with my friend in the UK. Again, we got some traction, but not enough for running it. for longer. I tried a dating app with another friend. We tried a virtual tailor where you can take your measurements in some 3D machine that is in some shops, in some countries, in some big cities, you have actually those shops where you can scan yourself, and we are building apps for fitting clothes for that. We tried some other adult entertainment, like we had a sex shop essentially with another friend who again lost his job, and we thought, okay, like what can we import from China, and we're selling some stuff with some twist of trying to market it as a website where we empower people to talk about their sexuality and so on. It also failed actually. Then there was a DeepArt that I will talk a little bit more. A virtual coach where you can record yourself and get some feedback from people from AI actually, and some company where we're collecting data for insurance. This took off as we wrote a paper on that, and it became quite popular, but failed for some team reasons in this case. And then there was Saliency.ai that was like the biggest success definitely from all of those, and I will tell you a little bit more about that. But as you can see, like when they tell about those entrepreneurs that basically most of the startups fail, I contributed to that a lot. Like I failed a lot of stuff in my life. So and it was failure in a sense of not getting it commercially viable, but all that contributed to building Saliency very quickly and efficiently through all those learnings that I had before. So just to mention about those projects, that I'm listing those projects, but those are really real projects. Like we really spend like half a year or a year on building an app or building software, writing papers about that. You can see the sex shop here. You can see the virtual fitting of clothes here, the machines for selling juices and so on. Like all that actually happened, and we had in all those cases we had some customers. So it's not just a joke kind of startup, and a few other. And one important one to mention is DeepArt, where we took a recent technology in machine learning and deep learning, and we tried to productize that. So with friends from Tübingen, and with their technology, actually, we built a website which can turn your photos into artworks. So you choose a picture, like you upload a photo, you choose a style of your artist that you like, and it generates this third image. So that's your photo in the style of the artist. And that took off a lot, like very substantially as a gimmicky web app and web tool, but like there was no viable business around that, unfortunately, even though like we had our 5 minutes of fame. And then came Saliency. Saliency is the project that I started around 2 years ago. And that started with a friend from Stanford. We were thinking, okay, where can we apply deep learning in AI and where it hasn't been applied yet. So we have seen a lot of startups running AI for healthcare, for diagnostics, and for giving more information to doctors. But is there any market that is not really covered yet? And we realized that actually clinical trials market is not, the AI is not that utilized yet. So we try to target this particular clinical trials market with 4 frameworks, which are basically what deep learning and machine learning for computer vision actually allows you to do recently. So you can automate 4 types of tasks. You can automate classification, where you have an image and you say that if it's a cancer, which is benign or malignant, you can say if an image is blurry or sharp. Then you have segmentation framework, where for a given tissue, you identify all the pixels that belong to these tissues. So here you can see the cartilage, femoral cartilage, so the cartilage on your femur bone. We have a landmark detection framework where you can identify any points on the body, and we have region of interest, where you can draw automatically boxes around objects that you're interested in. And all those are automated in the sense that if you feed a lot of data with those annotations manually performed, our system will learn that automatically. And the way it learns is that you have a set of tools that we built. The first tool is for actual annotations. So you get a picture MRI of a bone and you annotate cartilage. Then you can arrange the data for training the machine learning model in our tool. You click a button, then the saliency magic happens, and the saliency magic outputs a system that automatically finds the cartilage in the new image that you provide to the system. And this can be a web app, but it also can be deployed in any other system that is already there in clinical trials. So I just prepared a couple of use cases to just to show you examples. So you can find cartilage, you can find brain structures. In clinical trials, what turned out to be important is that sometimes when hospitals submit images for clinical trial, you have clinical trial of the liver, the image comes into the company running a clinical trial, then the doctor looks at this image and says that, okay, there's no liver, or we can see only half of the liver of this patient here. So the image or the call goes back to the hospital, and the hospital needs to contact the patient to come back and take another scan. So that's very frustrating. So we have a system for automating, figuring out whether the liver is visible or not. And then another problem in clinical trials is that you want to have all the data de-identified. So we built some, and it turns out that for MRIs, which are like 3D volumetric measurements of your body or brain in this case, you can actually reconstruct the face from this 3D measurement, even though it doesn't look like you can. If you use some fancy methods, you can render the face. And so we want to deface some patients, but like the important thing is not to change the rest of the MRI so that all the quantitative measurements on the scan will still be performed as they should. And the key part and why the Saliency was successful is that I had an awesome co-founder to work with on that. And so we were both working at Stanford back then, and we got along very well. And that's probably the key part why our customer actually wanted to acquire us. So let me talk about what I think I've learned in this experience. So I'm definitely not a founder like of a unicorn kind of startup, but we did in Saliency have like, I think around 300K revenue in the last quarter of our existence just before our main customer acquired us. So like it was a growing company. As you might have heard, I have a little baby. So that was one of the motivations to actually get the company sold at this point. If we were completely unconstrained, then maybe we would lead it forward. But like given the offer that we were given and the circumstances, it was just like an obvious call that we should sell it immediately and then maybe start something else after a couple of years where we work for the company that acquired us. So what I've learned, like that's my last slide and kind of a list of things that I think are important here. So first thing is that it's good to learn from mistakes. I took the harder path. I learned from my own mistakes and like a lot of failed startups, but you can also learn from mistakes of other people. That's a quicker and easier way to actually gather knowledge. Another related thing is that you can spend a lot of time on development, but sometimes it's worth to take a step back and actually look at what you are doing and talk with people who you are willing to sell to and learn whether what you are building makes sense. So I wrote it as a 1 month of the development can save you 1 day of research, or another way around, you can, instead of spending time on like building useless stuff, just think a little bit and talk with people. So there was this car dealership software that I built in my high school. I could have just go to those car dealers and ask them if they need that before I actually spent months on developing that. And then there's lots of boring advice that you can get when you read about startups and you talk with people. So Pedro mentioned that the team is extremely important, and the VCs and everyone in the space kind of mentions that it's actually more important than your idea. Like if the team is not good enough, or if you have some internal conflicts at the beginning with your co-founders, then it's worth just changing the co-founders rather than, even if your idea is brilliant, you'll just likely fail very, very quickly with the team that is not good to execute the idea. Execution is more important than the idea. In Saliency, that was important. Like we didn't have really an awesome patentable idea, but we were just talking to customers and executing without having a clear idea. And then the idea kind of came up when we talked to the customers. So that was important. Talking to customers, it's crucial. There's lots of them are on LinkedIn. Like and that's just one of the sources. But like you can always find customers to talk to. Use your skills and advantages. That's important. So like we were at Stanford, that was our advantage, but like we in the context of talking to customers, like people just wanted to talk with us because we're at Stanford. But there, ICL is also a good school. Like all the good schools have this feature. And you may have some data set that others don't have. You can have some skills that others don't have, and that makes like you have more chances to succeed in what you're best at rather than starting a new Chinese restaurant in London. Like just use your skills rather than an exciting idea. Solve problems. That's also obvious. After failing a couple of times, just don't build stuff because it's cool. Build stuff that people want to buy. And also, what we learned is that it's good to sell first rather than build first. And that's controversial, maybe. Like it doesn't sound completely ethical, but that's the only way to go. Like just talk to your customers, show them your prototypes as quickly as you can, screenshots of things that you know that you can build, and see that if they're interested or not. That's a quicker way and cheaper way to test your idea rather than building it. Dominate a niche. That's worked very well for Saliency. Like we focused on clinical trials, imaging in clinical trials, which is a very small market, but we were just the best, and 2 companies were interested in acquiring us in the space because like we're just the best ones in the space. Fund your company with customers' money. Like you find investors, but if you can find customers, that's 10 times better usually. But like that doesn't work for everyone. So in companies like Pedro's company, you need to build technology first to show that it works and so on. So like you need investors' money. But like whenever you have a business where people can buy it quickly, just sell it rather than looking for investors. Like you're not in the business of finding VCs, you're in the business of running a big company, and big companies need customers. And then finally, learn from others. Like there are lots of people who are willing to help. I'm very happy to help. Like just contact me on LinkedIn or email, and I will be happy to talk more about my experience or your experience. And there are lots of good materials online, especially if you haven't started like 20 different startups in the primary school. Then the YC startup school is really good, like for getting basics on like basic advice, like first sell then build. Like this is kind of YC approach to running businesses. So that's great. I will be happy to talk more in the discussion later. Thank you.
Our last speaker today is Rodrigo. Rodrigo graduated from UCL, sorry, my cat, with a PhD in computer science. And he's gone on to spin out a fintech company, which provides a lending platform called Refinery Tech, and also an app called from Applied Behaviour Systems Limited, which is an app combining nutrition, behavioural science, and biostatistics. And he's also a startup coach. So I'm sure Rodrigo will have lots of helpful insights for all of us. So I'll hand over to you if you want to share your screen. Rodrigo, thank you.
Yes, thank you, Ali, and everyone. Thanks for the invitation, and fantastic to be able to sharing here what is to be an entrepreneur. And I want to start talking about, there's a question there on the chat. Someone who is saying who is concerned about having a company because of the administrative burden that it would be legal entity, bank account, invoices, taxes, and so on. And then the fear of being successful too early. So let's start there. Yes, when you're an entrepreneur, you're going to have to deal with all that. Operations, basically, is how you would call it. And if you don't want to do that, well, don't do it, because you're going to have to do it. It's going to be 10 times harder than what you expect. And if you decide to continue working in academia or getting employed, it's fine also. But if you're going to be an entrepreneur, you will deal with that and many more things that you don't know. The second fear of being successful too early. Why not there? If you don't do it, then who's going to do it for you? Companies really don't care about us. You get employed, you have one client, the company. Why not being an entrepreneur than having many clients? You have less risk. That being said, I'll go straight into sharing what I consider probably is the most relevant ideas, and I'll build on what the previous presenter was saying. A PhD is the perfect training to be an entrepreneur, a postdoc. Why? Because you don't know what you're doing. You have a problem that you don't know how to solve, and you have to find a way. And this is exactly what you do as an entrepreneur. And it's all about building great products or services. So how do you do that? You really need to solve a problem for your customers. So just anyone here, could you tell me what a good problem is? Raise your hand or write in the chat, please. Anyone? Don't be shy. Someone, please help
I
me out.
think we have
A problem they will pay for good,
Henry from the Xeni, Sophia.
which doesn't have a solution.
Can you?
COVID.
Okay, so a good problem is painful enough, which implies that there is value behind it. There are enough people who care about it, means it is scalable. And they're actively trying to solve it. Timeliness, now and in the future. If you're not involved in a problem that has these characteristics, don't do it. Don't waste your time. If you decide to do it, just assume that maybe it's going to be a lifestyle business. For those who don't know what it is, a lifestyle business is a business that pays your life and your bills, which is also fine. But if you want something that is big, you need these elements. Now, how do you get there? So this workflow really explains how you do that. There's a need to identify a problem and then ask if it is a good problem. If it is not a good problem, get out of it. Stop wasting time. Life is too short. If it's a good problem, then build an MVP. And this is the first thing that I recommend to the startups with Homo. I am involved, or the companies with whom I'm an advisor. If you cannot build an MVP, don't do it. But if you can, then check if it solves a problem. And an MVP, many of you would just run away at that moment. Just think about that MVP for Dropbox was a video. They spent $3,000 to create a video that was sent to millions of people. That's it. If you had a shared storage that had these characteristics, would you use it? And they got a huge validation. It was so powerful that they raised funds on it. It is solving a problem as an MVP. No. Well, if it does, then can you sell it? You have a minimum sellable product. If you have one that sells, you achieve the value proposition status. Is no, you just wasted your time. And I want to go back to probably the first sentence of these slides. No, I think I don't have it here, which is a sentence from Rich Mironov. There is nothing there's nothing more wasteful than brilliantly engineering a product that doesn't sell. We've all done this. Don't do it. If you just remember one thing of what I said today, just write that down. I'll leave it there for a few seconds as you write it down. And I'll tell you why. We all can do engineering, build product, great things. But if no one cares or buys it, what was the point of that, right? Let's go back to the other one slide. So now that we reach that MVP capacity, we're really going into value proposition. And you have to be adamant about solving this and not skipping and not trying to divert. It's like when you write a good paper. A good paper solves one problem, talks about it, and goes all the way through. This is the same thing. If you solve a clear problem for a very specific segment by something very concrete, you are bringing value. And that is the way to go. So here I'll wrap up and leave it open to questions. How to take it from here? Well, analyze problems, get knowledge, understand the painfulness, the scalability, timeliness. Is there market penetration possible around it? Someone asked that answered on the chat that a good problem, there's a niche. Yes, absolutely. Is there a market for it? But more important, is there a market gap where you can start selling? What's the competitive landscape? Can you go there and build something unique that differentiates yourself and your product from others? Then do it. What type of assets do you have to do it? And then you try to just, again, pick one problem, determine a core value proposition, what is done for whom and how, determine a product roadmap, how you build it, who do you need, who is involved in that partnership as an internal association, as a team, or of companies, and how are you going to sell it, and allocate resources, and iterate, and just there, right? Sometimes overthinking hyper-analysis will just stop you. So it was quick and snappy. I hope it was interesting. Let's receive some questions.
That's great. Thanks, Rodrigo. I'm going to hand over to Ocean now to open up the discussion.
Thank you so much, Rodrigo. And I'm really impressed by how we should start up in a very structured way. And